Hello my dear champs, welcome to another wonderful session, and today in this session we are going to discuss the last topic of the chapter, carbon and its compounds. Okay, and the last topic is all about soaps and detergents. Okay, so we are going to discuss what are soaps and detergents, how is the cleansing action of soap taking place, all these things in this particular session. And by this session our fourth chapter about carbon will be completed. Okay, so let us start soaps and detergents. Okay, first of all, here let us discuss an activity which is given in your textbook itself. So here we need to take 10 ml of water each in two test tubes, that is A and B. We need to add a drop of cooking oil to both the test tubes. Okay, to the test tube B, add few drops of soap solution. Shake test tubes vigorously to get unclear mixtures. As we know, oil is not miscible in water, therefore they will form separate layers, right? But in the second test tube, along with oil and water, we have added soap solution too. So what happens in that particular case? Okay, so here we need to leave the test tubes undisturbed for some time. Oil layer separate out in both test tube, but this happens first in test tube A. Okay, this activity demonstrates the effect of soap in cleaning. Most dirt is oily and does not dissolve in water. Okay, in both the cases we can see oil will separate out in both the test tube. The oil layer will separate out, but it is separating out very quickly in the first test tube, that is in test tube A. Okay, and in the second test tube it is taking some time as we have added the soap solution to it, right? So we can conclude that most of the dirt, it is oily in nature and it will not dissolve in water. Okay, this is what you can see in test tube B, where we have added soap along with oil and water. Is this clear? Okay, now what are soap? Okay, so here comes the explanation of soap. Soaps are sodium or potassium salt of long fatty acids or long chain carboxylic acids are known as soap. So what is soap? Please note down. Soap molecules are the sodium or potassium salt of long chain carboxylic acid. Long chain carboxylic acids are known as fatty acids. Okay, the general formula of soap is, please note down, it is RCOO minus Na plus is the general formula of soap. Okay, note it down. Then examples are C17H35COO minus Na plus, C15H31CO minus Na plus, etc. Here you can see how many carbon and hydrogen are present in these cases. Here, if we are taking these given examples of soap molecules, you can see 17 carbon and 35 hydrogen are present, making it a long carboxylic acid, right? So we can call it as a fatty acid. So soap molecules are sodium or potassium salt of fatty acids. Okay, then soaps are made by which reaction? Saponification reaction. Okay, what is saponification reaction? An ester or reaction with what? Sodium hydroxide, right? We are getting alcohol and a sodium salt of carboxylic acid. So here we have discussed the saponification reaction, and these soaps are prepared by or made by this saponification reaction. Alkaline hydrolysis of ester gives soap. Okay, as alkaline hydrolysis of ester gives soap. Alkaline hydrolysis means we can take an alkali like sodium hydroxide. So this ester on hydrolysis using sodium hydroxide, we are getting alcohol along with the salt of carboxylic acid, which is the soap. Okay, then here you can see the reaction. Fat or oil, that is our ester, on reaction with an alkali like sodium hydroxide, and we are getting soap, that is a sodium salt of long chain carboxylic acid or sodium salt of fatty acid, along with glycerol, that is an alcohol. Okay, glycerol is an alcohol. Then how is the structure of the soap molecule? Okay, so molecule is having a particular structure. It is having a head portion and a tail portion. And what are the responsibilities of these two portions? Let me explain it in clearly. A soap molecule mainly has how many parts? It has two parts. An ionic part, that is CO minus Na plus, and a low hydrocarbon chain, that is a non-ionic part. So which are the two important parts of a soap molecule? It contains an ionic part and a long hydrocarbon chain, that is a non-ionic part. So an ionic part and non-ionic part is present in a soap molecule. Then the ionic part is hydrophilic. It is soluble in water but insoluble in oil. Okay, if we are taking the ionic part, here it is CO minus Na plus. This ionic part is hydrophilic. Hydrophilic means water loving. Okay, what is the meaning of hydrophilic? Hydrophilic means it is water loving. Okay, so this ionic part is water loving. It is hydrophilic. That means it is soluble in water but insoluble in oil. Okay, what does it mean here? It is soluble in water but insoluble in soil. Similarly, if we are taking the non-ionic part, which is the long hydrocarbon chain, it is hydrophobic in nature. Hydrophilic, if it means water loving, hydrophobic means it is hating water, water hating. That means it is insoluble in water but it is soluble in what? It is soluble in oil. Okay, so it is insoluble in water and soluble in oil. Okay, so what are the two parts of a soap molecule? Soap molecule has an ionic part and a non-ionic part. Ionic part is the CO minus Na plus part and the non-ionic part is the long hydrocarbon chain. Then what is the nature of this ionic part? The ionic part is hydrophilic. That means it is soluble in water but insoluble in oil. Whereas if we are taking the long hydrocarbon chain, that is a non-ionic part, it is hydrophobic. That means it is insoluble in water but soluble in oil. Is this clear? Okay, now moving on to the structure here. As you can see, this is how a soap molecule is. Here you can see the hydrophilic head in here. Okay, the hydrophilic head is present in here and the hydrophobic tail is too. Okay, so this is the hydrophobic tail, which is the long hydrocarbon chain, and this is the ionic part, that is the hydrophilic head. Is this clear? Okay, now the cleansing action of soap. Okay, as we know, for removing dirt from our clothes, we are using soap, right? And also to remove dirt from our body too. To remove dirt from any substance, we are using soaps, or we can use other forms of soap too, right? So how does this cleansing action takes place? First of all, we have studied the structure of the soap molecule, which is having a hydrophilic head and a hydrophobic tail, right? Now let me show you how this cleansing action takes place. First of all, most of the dirt from the activity, it is evident that most of the dirt, it is oily in nature. Okay, it is oily in nature. And which part of the soap is soluble in this oily dirt? It is the long hydrocarbon chain, that is a hydrophobic tail is the one who is soluble in this dirt, because dirt is oily in nature, right? Is this clear? So the hydrophobic part, which is a long hydrocarbon chain, it is soluble in oil but it is insoluble in water, isn't it? So most of the dirt, it is oily in nature, as because of which we can say that hydrophobic tail is soluble in this oil. Okay, in this oily dirt. Okay, in this oily dirt. Then some molecules have two ends, that is the hydrophobic and hydrophilic end. When soap is on the water surface, what happens? Its hydrophobic tail will not dissolve in water. Okay, what happens here? When soap is on the water surface, the hydrophobic tail, okay, it is not dissolving in water because it is soluble in oil only. Okay, instead the soap will align itself along the water surface with the ionic end in the water and the hydrocarbon tail extending out of the water. Okay, so how does this soap molecule align in the water surface? In the water surface, as we know, soap molecule has two parts, that is a hydrophobic tail and the hydrophilic head. The hydrophilic head, okay, the hydrophilic head, which is water soluble, it will remain in water, whereas the hydrophobic tail, okay, the hydrophobic tail, which is insoluble in water, will extend out of the water. Okay, this is how the soap molecule align at the surface of the water. Once again, when the soap is on the water surface, its hydrophobic tail will not dissolve in water. Instead, the soap will align itself along the water surface with the ionic end in the water. Okay, the head will be in the water and the tail will be extending out of the water. Okay, then what happens? Here a picture is also given and you can see the hydrophilic part of the soap molecules is there. Then this is the hydrophobic part of the soap molecule, and here you can see it is a oil particle. Okay, when what happens, let me explain it very clearly here. When these molecules are in water, they are arranged in a way that keeps the hydrocarbon part out of the water. Therefore, clusters of molecules where the hydrophobic ends are inside the group and the ionic ends are on the outside of the group, this cluster of molecules is called an micelle. So what is a micelle? Here you can see when an oil particle is present. Okay, that means when dirt is present. As we know, the hydrophobic tail is soluble in the dirt, right? So what happens if there is an oil particle present? The hydrophobic tail, okay, it will align in such a way that it is soluble in the oil. So here you can see the hydrophobic part. So the hydrophobic part of the soap molecule is inside the oil, and the hydrophilic part, which is soluble in water, will extend out near the oil molecule or the dirt molecule, thereby forming such a structure. Okay, thereby forming such a structure, and this cluster is what we can call as micelle. Okay, so when these molecules are in water, they will arrange in such a way that it will keep the hydrocarbon part out of the water. Okay, it will keep, so molecule always keeps the hydrocarbon part out of the water molecule, and if dirt is present, it will insert this particular hydrophobic part inside this oil molecule or the dirt molecule. Therefore, the clusters of molecule where the hydrophobic ends are inside the group and the ionic ends are on the outside of the group, this cluster is what we can call as micelle. Okay, this cluster is what we can call as micelles. Then micelles have an important part in the dissolution of dirt and oil in water, hence facilitating the cleansing of or the cleaning of cloth. Okay, so when there takes place the formation of the micelles around this dirt which is present in our cloth, and due to ion-ion repulsion, micelle does not precipitate and stays as colloids in the solution because of the ion-ion repulsion. Okay, if there is a micelle present, okay, if there is a micelle present here, this is one micelle. Okay, and there is another micelle present around it. Okay, so what happens here? This is the head is what it is the ionic part, right? So there is charge in the head and negative charge will repel. That is what meant by due to the ion-ion repulsion between these micelles, it does not precipitate and stays as colloids in the solution. And on agitation, these micelles are removed along with the dirt. Okay, and on agitation, what happens? These micelles, they will remove along with the dirt, and this is what happens during the cleansing of cloth. Is this clear? I hope the cleansing action of soap is very clear to you. Now here you can see that picture which is given in your textbook already. So this is how the cleansing action take place. If there is dirt present, what happens? There is the hydrophilic end and the hydrophobic end and the grease or dirt present. The hydrophobic end will comes and attaches or extend into the dirt or the grease, and the hydrophilic part will extend it to the water molecule. So here, as you can see, thereby taking place the formation of what we can call as the cluster, that is what micellae is. So here there takes place a micellae formation. Right, there takes place a micellae formation, and due to the ion-ion repulsion, they will exist as colloids in the solution, and on agitation along with the dirt, they will be removed. Here you can see, first of all, it is present in the cloth, then after the micellae formation, it will leave, and on agitation, it will leave the cloth. Okay, that is how our clothes are getting clean, and this is a cleansing action of soap. Okay, is this clear? Now, here, let us discuss about the water containing sulfates or chlorides or hydrogen carbonates of calcium or magnesium. Do you know the name of it? It can be called by the name hard water. Okay, the hard water, okay, as we can find in our washrooms, okay, there are kind of some stains, water stains present in the in the tools in there, like in the tap or the shower that we are using, we can find some water stains present on it. It is because of the water containing the salt. Okay, that means it is hard water. So what is hard water? It is a water containing sulfates, chlorides, hydrogen carbonates of calcium or magnesium. We can call it as hard water. Example, water from tube well or hand pump. Okay, these are all hard water. And here, if it contains what the salts of calcium or magnesium ions in more amount, it is what hard water is, and it is difficult to produce foam by soaps in hard water. Okay, if we are using soaps in hard water, there will be less foam production by the soap. So bathing and washing become difficult. Okay, after washing, an insoluble substance which is scum remains in hard water. Okay, so if we are using soap in hard water, there will be no enough lather formation by the soap, and also the bathing and washing becomes difficult in that case. And also after washing, we can see a kind of an insoluble substance, that is what we can call as scum. Okay, so soap form scum in hard water. So here I am saying soap is not effective in hard water. Okay, soap cannot work well in hard water, and it is because of the presence of sulfate, chlorides or hydrogen carbonates of calcium or magnesium. Okay, then how can this problem be solved? If soap cannot work in hard water, and if there are areas in which there is only hard water, how will we perform the cleansing action? Okay, so here it can be demonstrated by the following experiment. The scum formation in hard water. First of all, we need to take 10 ml distilled water or rain water and 10 ml hard water in separate test tubes. Hard water can be prepared by dissolving salts of calcium or magnesium in water. Okay, so first of all, we are taking 10 ml of distilled water and also 10 ml of hard water in separate test tube, and we can also prepare hard water by dissolving salt of calcium or magnesium in water. Then we need to add few drops of soap solution to both and shake well for some period. Okay, test tube with the distilled water gets more foam. Okay, it will easily form the lather, or it gets more foam, whereas test tube with the hard water gets white curdy precipitate. As you can see here, if we are taking the rainwater or the distilled water, we can call it as a soft water too. There takes place the rapid foam formation, whereas in the second case there is kind of a curdy precipitate formed, right? The test tube with hard water or the conical flask which contains hard water gets white curdy precipitate, and this scum or precipitate is caused by the reaction of soap with the calcium and magnesium salt. Okay, when soap reacts with the calcium and magnesium salts present in the hard water, it is resulting in the formation of this white curdy precipitate which we can call as scum. Okay, then we can solve this problem by using detergents. Okay, so soap is not much effective in hard water. It will result in scum formation, so our cleansing action cannot be performed very well, right? Because of which, instead of soap in hard water, we can use detergents in hard water. So what are detergents? Let me tell you. Detergents are generally sodium salt of sulfonic acid or ammonium salts. Okay, so what is soap? It is the sodium or potassium salt of long chain carboxylic acid is what we can call as soap, whereas detergents are the sodium salt of sulfonic acids or ammonium salt with chloride or bromide ions, etc. So detergent is kind of different from the soap. So they are sodium salt of, please note it down, sulfonic acids or ammonium salt with chlorides or bromide ion, etc. These are effective in both hard and soft water. Okay, hard water contain the salts of calcium and magnesium. But even though detergents are very effective in both hard water and soft water, soap, when it reacts with the calcium and magnesium salt present in hard water, it will result in the formation of an insoluble substance called scum. Isn't it? It results in the formation of an insoluble substance that can be called as scum. And in contrast, the charged ends of detergents do not contribute to the formation of insoluble compounds when exposed to calcium and magnesium ions present in hard water. Okay, the charged ends of detergents, okay, they will not contribute to the formation of insoluble compounds when exposed to the hard water. That is, in hard water the calcium and magnesium ions are present, right? Detergents show efficiency in cases of hard water because these detergents are sodium salt of sulfonic acids or ammonium salt. Then they are usually used in the production of shampoos, laundry products, etc. Okay, these detergents are used in the production of shampoos and laundry products, and the efficiency of detergents can be demonstrated by this particular experiment. Okay, we need to take 2 test tubes with 10 ml hard water in each. Okay, we are taking hard water in each test tubes, and here we are going to check it with soap and detergent. Okay, add 5 drops of soap solution to one and 5 drops of detergent solution to the other. Shake both test tubes for the same period. The test tube with detergents gets more foam. Okay, the one which contains detergent is forming more foam. In test tube with the soap, curdy precipitate is formed. Okay, curdy precipitate is formed in the test tube that is containing the soap solution. So soap is ineffective in hard water, whereas in hard water means the water that contains the salt of calcium and magnesium. In that particular hard water, we can make use of detergents. Detergents are sodium salt of sulfonic acids or ammonium salts containing chloride, ion, bromide, etc. Okay, so detergents are effective in hard water. Okay, is the portion clear? Is this clear? Okay, I hope so. Now let us discuss some of the NCERT in-text questions. So this is all about the content in our 4th chapter, and what are the questions from this topic? Let us check. How would you distinguish experimentally between an alcohol and a carboxylic acid? It is a previous year question in 13, 16 and 17. So how will we distinguish experimentally between an alcohol and a carboxylic acid? Alcohol is a substance. What is the nature of it? It is a neutral substance, whereas carboxylic acid is acidic in nature, right? And we have studied about some important compounds, right? Ethanol, which is an alcohol, and ethanoic acid, that is a carboxylic acid. Okay, now let us check the answer. Alcohols can be distinguished from carboxylic acid by the reaction with a base and also by the reaction with sodium bicarbonate. What happens when these compounds, that is an alcohol and a carboxylic acid, reacts with a base. As we know, acid reacts with a base to form salt and water, whereas an alcohol has no reaction with a base, isn't it? So alcohols, they will not or do not react with bases, whereas carboxylic acid react with bases like NaOH and KOH to produce salt and water, and we can write the reaction as sodium hydroxide, that is NaOH, on reaction with carboxylic acid like ethanoic acid or acetic acid result in the formation of salt along with water, whereas if we are taking an alcohol like ethanol in the case of the instead of the carboxylic acid, and on reaction of it with a base like sodium hydroxide, there will be no reaction. Okay, so the first test that we can use to distinguish between an alcohol and a carboxylic acid is by reacting them with a base like NaOH, right? So an alcohol on reaction with a base, there will be no reaction. A carboxylic acid on reaction with a base, there forms salt and water. Is this clear? Okay. Now the second reaction is the reaction of these alcohol or carboxylic acid with sodium bicarbonate. As we know, acid reacts with a metal bicarbonate, resulting in the formation of salt, water and carbon dioxide gas, whereas alcohol has no reaction with sodium bicarbonate. Okay, let us check. Similarly, alcohols do not react with sodium bicarbonate, whereas carboxylic acid react with it to produce salt, water and carbon dioxide gas, and we are studying this particular reaction from the second chapter itself, right? So here comes the reaction, acetic acid or ethanoic acid on reaction with sodium bicarbonate, NaHCO3, there forms a salt, CH3CONA, along with water and carbon dioxide, and ethanol on reaction with sodium bicarbonate, there is no reaction or it has no reaction. So by these two reactions, we can distinguish or experimentally distinguish between an alcohol and a carboxylic acid. We can make use of a litmus paper too. Okay, if we are dipping a litmus paper in an alcoholic solution, there will be no change on the color of the litmus paper. So it is neutral in nature. And in a carboxylic acid, what happens? The litmus turns red. A blue litmus, if it is a blue litmus, it turns red. Therefore, we can conclude it is an acid. Okay. Moving on to next question. What are oxidizing agents? It is a previous year question from 2012 and 2013. What are oxidizing agents? Oxidizing agents are those which undergoes a reduction, but they are helping others to get oxidized. That is the reason why they are known as oxidizing agents. Do you remember in the second chapter and also in the third chapter we have discussed about oxidizing agents? So substances that are capable of donating oxygen for the oxidation of other substances are called oxidizing agents. Themselves they are getting reduced, right? By reducing themselves, they are helping others to get oxidized. Okay, so substances that are capable of donating oxygen for the oxidation of other substances are called oxidizing agents. Examples of oxidizing agents are alkaline K1O4, acidified K2Cr2O7, etc. are some of the examples of oxidizing agents. Okay, next question. Would you be able to check if water is hard by using a detergent? It is a previous year question from 2013 board examination. Are we able to check if water is hard by using a detergent? Detergent is effective in both soft and hard water, whereas if we are taking a soap, it is effective in soft water only, but it is ineffective in hard water. So here detergents form lather in both the cases. In both soft and hard water, detergents will form lather. So here we are not able to identify which is hard water or which is soft water, right? So it is not possible to check if water is hard by using a detergent. So detergents, they form lather in both soft and hard water. So it is not possible to check if water is hard by using a detergent. Is this clear? Okay. Now the next question. People use a variety of methods to wash clothes. Usually after adding the soap, they beat the clothes in a stone, beat it with a paddle, scrub with a brush, or put the mixture in a washing machine. Why is agitation necessary to get clean clothes? It is a previous year question of 2012. Okay, why is agitation necessary? How is the cleansing action of soap taking place? It is taking place by the formation of the clusters that can be called as micellar formation, right? So micellar will be formed around the dirt particles, and in order to remove those clusters, we need to agitate it, right? That is the reason why agitation is necessary. So how we can write the answer? Note down. The addition of soap to water results in the production of micellar, in which soap attracts both greasy dirt and water. As a result, the formation of an oil in water emulsion occurs. Agitation is necessary to remove the loose dirt particles in the form of micellar from the cloth surface. Okay, in order to remove that clusters, agitation is necessary. So this is how you need to answer the question. So that's all about today's session, and today in the session we have discussed the last topic of our chapter, carbon and its compounds, that is all about soaps and detergents and the cleansing action also. Along with we have studied that soap is effective in soft water only, and detergents, if you are taking it, they are effective in both soft water and hard water. Isn't it? So I hope the session is very clear to you. So we will meet in the next session with the NCERT exercise questions along with the previous year questions. Okay. So I hope the concepts from this particular chapter is very clear to you. We will meet in the next session. Until then, happy learning. Thank you.